All right, we're actually in the end game of our course content at this point. We wrapped up talking about exponentials, and we're actually going to get a bit of a break from dealing with them and their cousins' logarithms here because we don't specifically need them for this particular section. Um, so we're going to be talking about financial calculations. I've already let the cat out of the bag a bit that they're largely going to be focused on ideas of interest building. So you can see the word interest sitting on the board behind me already. So this first concept, again, it doesn't use exponentials. Most everything else we're going to see after this will in some way, shape, or form. We don't directly use this notion of what we call simple interest that often by itself, but it turns out it's kind of underlying a lot of what we're going to be doing going forward. So let's go ahead and dig into it. So as usual, I'm assuming you've got the notes file sitting with you while you take a look at this in some form or another. So the formula for calculating simple interest looks like this. So I equals PRT. The letters here, hopefully, as the variables, hopefully stand to reason. I for interest, P for principal, that's the amount you've invested. These ideas also work for if you're borrowing money. In that case, principal would be whatever you took from the bank or the lender, whomever. R is an interest rate, and T is a measurement of units of time. So principal times rate times time. So that's the base format here. The one thing I do want to point out, and the notes file points out the same thing, the time scale for the interest rate and T, the time scale, they need to agree. So most interest rates are given to you on an annual basis, which means that by and large, we're going to need to calculate T in terms of years. So just keep that in mind. You'll see some of the examples will toss a time frame at you that's not specifically years, and you're going to have to convert it. One last thing, make sure for everything we're doing in this chapter, make sure you convert any interest rate that appears from a percentage into a decimal. If you don't, things will go really sideways. So let's take a look at some examples here. So we give you a case where somebody socks away $4,500. They let it sit and cook for 3 years at an interest rate of 7%. And we want to know how much interest they've built up. So we're told in this instance that $4,500, that's our principal. The interest rate is 7%. Again, we don't use the 7 directly. So move the decimal point twice. So 0.07, not 0.7. That's a 70% interest rate. And if you report that, you'll probably have government watchdogs coming after you. And then we've got a time frame of 3 years. These already agree. We don't need to do any fancy footwork there. So now we can just fill in the blanks and work out the calculation. We have 4,500 times 0.07 times 3. When I worked out the arithmetic here, I got an interest buildup of $945. So pretty straightforward in this instance. Let's take a look at the next one. So same setup with one slight twist. So we borrow $5,000, so we can still use the formula as calculated. So our principal is still $5,000. So that part works out. We're given an annual interest rate of 12%. So I'll go ahead and convert that into a decimal of 0.12. The catch is the time frame here isn't in years. It says 39 weeks. So that doesn't jive with this. This is an annual rate. We took great pains to point out the annual rate, even though it's kind of the industry standard. So instead of just plugging in T equals 39, yeah, that's not going to work. That's grossly overselling how much interest you're going to be able to build up. So we got to take that 39 and divide it by the number of weeks that would occur in a year in order to get a number of years. So there are 52 weeks in a year. There's a little bit more, but you get the idea. So 39 divided by 52 would give me 3/4. If you wanted to report it as 0.75, it's all good. So our interest in this instance, we've got 5,000, 0.12 times the 3/4 or 0.75, tomato, tomato. And we work out the arithmetic there. I got $450. So Again, just trying to keep you on your toes. Make sure you remember that when we calculate, an interest like this, we need the time frame in years because like 99 times out of 100, the interest rate you're going to be given is on an annual scale. So that's that. Now, one factor that we're going to end up seeing come up a lot going forward, we're not going to be interested, no pun intended, just in how much interest we build up. We'll talk about what we call the future value, how much we'll actually have in the account if we just assume the interest gets dumped in there, that sort of thing. So future values, in our text, they're pretty universally referred to using the letter S. So it looks like principal plus interest. So S equals P plus I. This formula comes in handy a time or two. I actually find it more useful working with it from a pure, slightly, manipulated standpoint. I like feeding in that simple interest formula that we saw earlier. So P plus PRT, because you'll see there's a handful of examples where we actually need to extract like how much we want to invest, and it's a lot easier from this format instead of just having I floating around in there. We can also clean this up a bit because you'll notice both copies of both terms here have a factor of P on them. So I'd have S equals P times 1 plus RT. The parentheses are important. Also, factoring a P off here doesn't give you a 0, gives you a 1, just making sure we're all on board. Okay? Okay. Let's take a look at a couple of examples of this future value thing in action and see what we're shooting for here. So we're given another loan problem next. We borrow $3,000, says for 6 months, so you can convert that into half a year. Hopefully that makes sense. We're given our simple interest rate. It's 15%, which, ouch. And so we want to figure out the future value of the loan, how much we end up having to pay back in total, essentially, here. So in this instance, we've got our P of $3,000, R 0.15, the T, I'm going to go ahead and write it as 1/2 because, again, it was 6 months out of the 12 months in a year, so there we go. So I'll do this kind of using the base formula and then, add in the principal to get our future value. So we just feed these guys back in to that fellow right there. So we have 3,000 times 0.15 times 1/2. Again, 0.5 is perfectly fine as well. I got $225 in interest. To get the future value, I roll that interest in with the initial amount we borrowed. So S is going to be our principal, the $3,000, plus the interest of 225. So this loan ends up costing us, when it's all said and done, $3,225. So again, I'm not an investment guru by any sense. That feels like a lot of interest to build up really fast, but yeah, that's a pretty beefy interest rate. So one example down, one to go. All right. So the other example works kind of in like a forecasting standpoint. So we have ourselves an investor, and they want a certain amount of money in a certain time frame. We're told we need $25,000 on hand 10 months away from now. And we're given an available interest rate of 4.95%, and we need to figure out how much do we need to put away now to hit that total 10 months away. So this time around, we don't have a principal. We have the future value target. So we have this kind of awkward, 4.95 interest rate, and the time frame was 10 months, so it was a fraction of years. It would be 10/12. Be careful if you make this a decimal here. Don't round too aggressively because that decimal isn't going to terminate for you. So we've got S, we've got R, we've got T. If we use this formula right here, we can plug in all the relevant values and figure out what's going on and then isolate the principal because that's the amount we got to put away. So we have 25,000 equals P times 1 plus our R is this awkward 0.0495. And now we can just divide both sides of this equation by the, awkward thing in parentheses. So if you had worked out what this number is, that's fine. Just be careful with your rounding. I'm probably going to regret trying to write this in. So here, those guys go away. P is left by its lonesome. When I pounded out all the arithmetic here, it doesn't work out to give me, a nice clean number. So that ugly interest rate probably clued you in anyway, just in case. I got $24,009.60. So a lot of our homework problems are working from the standpoint of you round things to the nearest cent every now and again, be on guard, it may say to the nearest dollar, but yeah, 24009.60 if you round it to the nearest penny. So that's a starting point for this. I want to take a look at a few more examples before we draw the curtain on simple interest. So keep watching.